Now that we've learned some basics about matrices, today we're going to look at multiplying matrices. Before I can multiply matrices, we have to make sure that it's even feasible for me to do that. So what we do is we write the dimensions of the first and the dimensions of the second. For matrices, order matters for multiplication. It's not commutative like your normal arithmetic is. So in order for me to be able to multiply, the columns of the first matrix has to be the same as the number of rows in the second matrix. So these must be, sorry, I'm using a new stylus, must be same to multiply. There we go. And then your A of your first matrix or your row of the first matrix and your column of the second matrix gives you the dimensions of your final answer. Now I want you to look at this page. Do you notice that it's the same problem written 6 times? Okay? That's because my process for multiplication is a little bit more complicated. And I just want to give you a visual of what is going on when we do multiplication. And on the next 4 problems, I will show you a strategy using basically the box that we're used to help organize it. So don't get overwhelmed on this screen, just as a forewarning, but it's trying to write out the different steps. But really, we're going to be able to do these problems quickly, so don't get deterred. So what we're going to do is when we multiply, you take, in this case, the first row, and we're going to multiply each element to the first column. So what we're going to do is do 6, that's the first element, times 2, that's the first element in the second matrix, and we're going to add 0 plus 0 times 0. Well, 6 times 2 is 12, plus 0 is 12. So that goes in my first spot, 12. Now I'm going to keep doing the 6 and 0, but I'm going to now move and do my second column. So for this, I'm going to do 6 times -1 plus 0 times 5, which will give me -6. You with me? First row times third column. 6 times 3 plus 0 times 1 gives me 18. Now I'm going to repeat the same process, but I'm going to use the second row every time. So second row, first column, 4 times 2 plus 7 times 0. So 4 times 2 is 8, and then 7 times 0 is 0. Second row, second column, 4 times -1 plus 7 times 5. So that would be -4 plus 35. So that would be 31. And then we have second row, third column. 4 times 3 plus 7 times 1, which would be 12 plus 7, which is 19. Okay? So that was kind of long. What I'm going to show you how to do has to do with stacking these to make it like multiplying with the box. Now we're going to look at how to multiply this using it's not really the box method, but using the box method. And to do that, you have a lot of space, so I want you to write your matrices pretty big so that you have room to do the work for it. I don't care how you multiply this. If it made sense with it the way it was structured on the front, that's fine. But I really liked when I saw this method what we're going to do is we're going to split up and draw lines like this. Okay, so that means my final matrix, by the way, is going to be a 3 by 2. But I usually put stuff in at the end. So now we're going to do what we did on the front, which is I'm going to multiply my first, we're going to go into this box right here. So I need that row times that column. So 5 times 2 is 10. Negative 3 times 4 is negative 2. Or sorry, negative 12. I'm already doing 10 minus 12 is negative 2. Sorry, jumping ahead. Now I'm in this box. So I'm going to do 2 times 0 is 0. Negative 3 times 7 is negative 21. Now I'm going to move down. 0 times 5 is 0. 5 times 4 is 20. And let's see if this shows up. 0 times 0 is 0. 5 times 7 is 35. And going to the bottom, negative 2 times 5 is negative 10. 0 times 4 is 0, so that'll be negative 10. Negative 2 times 0 is 0. 0 times 7 is 0. So then my bottom is going to be 0. All right. And this worked because I had a 3 by 2 and a 2 by 2. So since these middle ones matched up, that was fine, and my resulting matrix was a 3 by 2. So let's look at this next one. I have a 2 by 2 and a 4 by 2. So since these ones don't match up, this is going to be undefined. I cannot multiply these matrices together. And if you would try doing it when you're setting it up, I'm just going to do the very first part. 0 and 8, and then up here you have 7, 2, negative 1. You don't need to write this. 9, but someone out there is curious. I multiply my 0 and my 7, my 2 and my 8, but I have nothing to multiply to the negative 1 and 9, so that's what lets you know you can't do it. Okay, so let's try this one. Once again, I'm going to split it up and show you doing it with the box. 2, 0, 6. 1, negative 3, 4. And we'll real quick check the dimensions. So my first one is a 3 by 1. My second one is a 1 by 3. So they match, which is good. And that means my resulting matrix is going to be a big one. It's going to be 3 by 3. I mean, not really big. Like if you ever do this in college, then they get like really ginormous and you cry. But that's okay. We're not in college right now. We're in Algebra 2. All right. So I'm going to do 2 times 1 is 2. 2 times negative 3 is negative 6. 2 times 4 is 8. 0 times 1 is 0. What's going to happen in that whole row? That whole row is going to be 0. All right. 6 times 1 is 6. 6 times negative 3 is negative 18. And 6 times 4 is 24. So my final matrix would be 2, 0, 6, negative 6, 0, negative 18, 8, 0, 24. Okay, one more. So I'm going to drop the first one down a little bit. And I know some of you will probably get lazy and just squish this underneath the written problem. I mean, you do you. I don't care as long as you're getting it right. Split it up a little bit. Okay. And you could tell maybe that this one is going to work because we have a 2 by 2 and a 2 by 2. And so my final one is going to also be a 2 by 2. All right. So I have 3 times 7 is 21. 9 times 1 is 9. Then 3 times 0 is 0, plus 9 times 3 is 27. 2 times 7 is 14. Negative 1 times 1 is negative 1. 2 times 0 is 0. Negative 1 times 3 is negative 3. So my final matrix is 21 plus 9 is 30. 0 plus 27 is 27. 14 minus 1 is 13. And 0 minus 3 is negative 3.